Here's an example of going backwards from a graph to an equation. This is a simple version of modeling some sort of oscillation by a sine or cosine function. So we're given a graph here, what certainly looks like a sine wave. So let's say it really is a perfect sine wave, but we don't know exactly how the sine or cosine function has been modified, and we want to write out a match. So in particular, it's going through minus 1/2, comma 0, 1/2, comma 2, and 3/2, comma 0. Let's say those are exactly the points they look like they are. And the task is to find an equation of the form of a modified sine graph that matches this. Now we could use cosine. Usually in book problems you're asked to find one or the other, but sometimes it's just use either. So I'm going to go ahead and go with a sine. Depending on exactly what you're shown, one is easier than the other, but it's not a big deal. It's always possible to use either. Now, some books, the book that we're using this year, writes this as bx minus c, which has some slight advantages. Um, and various other forms can show up in terms of the argument of the sine function. The main thing to note is, apart from just how you label the letters, it doesn't really matter, and what I'm going to show you is going to work for any form. It turns out to be slightly easier for various forms. Okay, so the main thing is to not kind of dig directly into the algebra here, but to think about the qualitative features of the graph. And this is very much like what we would do if we were going the other direction, from equations to a graph. We want to find things like the center line, the amplitude, the period, all these important qualitative features. Well, the center line looks like, okay, it's going between 2 and minus 2. Well, let me say it really is going down to 5/2 minus 2 here, just to be really clear about that. Okay, so it really is max 2 and min minus 2. If it's a perfect sine wave, which we're supposed to assume here, then the center line is in between. So it happens to be that's y equals 0, and therefore there's no vertical shift. Good. Okay, that makes it a little simpler. So we can go ahead and just not even worry about d. The amplitude is another really crucial thing to pick out of this. Well, now we know the center line. By definition, the amplitude is just the distance from the center line to the max or to the min. It's the absolute value. It's always a positive number. And so that amplitude is going to be 2. And that means we can choose A to be 2. Now, we might, for some reason, want to have a negative here to have an upside down sine wave. But usually you wouldn't do that if you don't have to. Okay, so we got A and D already. All right, the next super important thing, maybe even more important than the previous two things, is the period. Okay, so the period, we're going to read that off the graph. I find that to be tricky for some students because people tend to look for the wrong features and let their subconscious do the work. Like they would look maybe for this intercept and then try to guess the next point. Well, that's not necessarily nice. So look for nice points, so especially if points are specifically given to you. Okay, so for example, the minus 1/2 here is an up crossing of the center, and the next crossing of the center is a down crossing at 3/2. That's this point here and this point here. Now that's not one period, that's half a period. And so half a period is going to be the 3/2 minus 1/2. So let's actually go ahead and write that down. Half a period is visible as 3/2 minus the minus 1/2. And that's 2. And so period equals 4. Now, what do we actually want? We want the b coefficient in front of the x here. Okay, so that means we have to just remember how that relates. We know period in terms of b, always that's 2 pi over b. 2 pi over b. And that solves very nicely as b equals 2 pi over period. So that's a very nice thing to remember. You don't have to memorize this separately. You can always just solve this equation. Okay, so that's going to be 2 pi over 4 or pi over 2. Now this is interesting. You don't always see this. In the very, very simple basic examples we start with, we tend not to see these. But there's a pi in the b here. And that has to happen if the period doesn't have a pi in it. The period here wasn't something that had it wasn't some sort of nice rational number times pi, and that means that the b has to have a pi in it to cancel. Okay, so we got pi over 2 for b. Now the trickiest thing is the phase shift. And c. And the key thing is that unless you use a rather different form, which this book does not use, they are not equal. They are related, but they're not equal. Just like the period was not equal to b, we had to do a little algebra. Okay, and the way I like to say this, that's insensitive to whatever exact form you're going to use here, is we look at the anchor point strategy from the other videos of graphing from an equation. And the key thing was to solve the equation bx plus c equals 0. We're trying to fake out the sign. If we're trying to find the anchor point from the equation, we try to fake out the sine function to make it start its cycle. Well, suppose we know where the anchor point is, we can still solve this equation, but with a different unknown. So let me show you how that works. Okay, so this is really still the absolute most important thing in the whole process, but the algebra just works out in a slightly different way. Okay, so the anchor point here is known. Kind of like here the period was known and we found b in terms of that. Here the anchor point is known. That's an x value. The special x value, okay, well, let's see. It's a sine function. Here's where we really need to use that we're modeling it as a sine. We're not flipping it upside down, so the anchor point should be an up crossing of the midline. It should be right here. That's minus 1/2. So the anchor point is at minus 1/2 comma 0, or in other words, the phase shift. That's the name for the x coordinate of the anchor point, is x equals minus 1/2. Okay, don't plug that in for b. We're going to plug that in for x here. Okay, and then we're going to be able to solve. So we actually have all the information we need right now. We know that pi over 2 times minus 1/2 plus c should be 0. Because if we solve this equation with a known c, which we're going to find in a minute, but we don't know yet, we should get x equals minus 1/2 as the solution. We're just reversing that process. This is still the condition for the anchor point to be the anchor point, and it's just that we don't know c here, but it's really easy to solve. Okay, c is just going to be, push that over, it's going to be pi over 4. So now we're done. Y equals 2 sine pi over 2x plus pi over 4, and then plus 0, but I want to include that. Now, the only difference between this and our current book is that they do tend to write this with a minus sign. So they would call this, they would change the sign of c. However, this answer would not be different. This answer is just what it is. It would be pi over 2x plus pi over 4. And then the only thing, are you thinking of this as just plus pi over 4 or minus a minus pi over 4? So we'll talk about that in class. I hope that won't be too confusing. The main thing is it doesn't matter what you call it, you just need to get a correct equation that actually graphs what you want to graph.